On March 7, 1945, American soldiers advancing toward the Rhine River near the small German town of Remagen witnessed something they had been told was impossible: an intact bridge still spanning the river that was supposed to be Germany's final defensive barrier. The Ludendorff Bridge, a massive railroad structure built during World War I, stood damaged but functional, its western towers scarred by failed demolition attempts, but its roadbed still capable of carrying traffic. For 10 crucial days, that bridge would become the most important 1,000 feet of real estate in Europe, a gateway allowing Allied forces to cross the Rhine without conducting the costly opposed river crossing operations that planners had expected would be necessary. But keeping that bridge standing required combat engineers performing some of the most dangerous work of the entire war, defusing German demolition charges while under artillery fire, constructing support structures while the bridge swayed and creaked under the weight of vehicles and troops working in cramped spaces beneath the roadbed where any structural failure meant death by drowning or crushing, all while German forces threw everything they had at the bridge, trying to destroy it before it could be secured. The engineers who worked on the Ludendorff Bridge accepted casualty rates that would have been considered catastrophic for infantry assaults, yet their work was essential. Without engineers, the bridge would have collapsed within hours, the breakthrough would have been lost, and the war might have lasted weeks or months longer. This is the story of Remagen, where engineers proved that victory required more than just fighting. It required building, repairing, and maintaining the infrastructure that made modern warfare possible, even when doing so meant dying in ways that earned no medals and made no headlines. To understand why the Ludendorff Bridge was so strategically important, you need to understand what the Rhine River represented in March 1945. The Rhine was Germany's last major natural defensive barrier, a river too wide and fast-flowing to cross without specialized equipment and preparations. German forces had been retreating steadily since D-Day, but Allied logistics and the difficulty of advancing through destroyed infrastructure meant the pursuit was slower than hoped. German planners expected the Rhine to provide time to reorganize shattered units, time to bring up reserves, time to fortify the eastern bank. The assumption was that the Allies would need weeks to prepare for Rhine crossings, that every bridge would be destroyed, that the river would buy Germany precious time to extend the war and possibly negotiate better surrender terms than unconditional defeat. The Ludendorff Bridge was built during World War I to transport troops and supplies to the Western Front, named after General Erich Ludendorff, who was one of Germany's principal military leaders. It was a massive structure, 1,069 feet long, supported by 3 stone towers and a series of steel spans designed to carry heavy railroad traffic across the Rhine between Remagen on the west bank and Erpel on the east. By 1945, the bridge was obsolete for its original purpose. The railroad had been damaged by Allied bombing, and the bridge itself was no longer critical to German transportation networks, but it remained tactically significant as one of the few Rhine crossings in the region. German engineers had prepared the bridge for demolition, installing explosive charges that could drop the structure into the river on command, as they had done with every other Rhine bridge as Allied forces approached. American forces reached Remagen on March 7, 1945, with the 9th Armored Division spearheading the advance. The division's orders were to advance to the Rhine and secure the west bank, not to attempt any crossings. Higher command assumed every bridge would be destroyed and that formal crossing operations would be planned and executed methodically. When lead elements observed the Ludendorff Bridge still standing, there was a moment of disbelief, followed by immediate recognition that this was an opportunity that couldn't be ignored. Officers on the scene made rapid decisions: attempt to capture the bridge before the Germans could detonate their demolition charges, accept the risks of crossing a structure that might explode at any moment, and deal with whatever consequences came from exceeding orders. The initial assault to capture the bridge was conducted by infantry and armor moving under fire across the structure while German defenders attempted to stop them, and while German engineers frantically worked to trigger demolition charges that were supposed to have already destroyed the bridge. Soldiers described running across the span while hearing secondary explosions from demolition charges that only partially detonated, feeling the structure shake beneath them, wondering if the next step would be their last before the entire bridge dropped into the Rhine. The crossing succeeded. German defenders were overwhelmed before they could destroy the bridge, though they managed to damage it significantly, and by the end of March 7th, American forces held both ends of the only intact Rhine bridge in Allied hands. But capturing the bridge and keeping it operational were entirely different challenges. The structure was damaged, Partial demolitions had weakened supports, artillery fire had struck the towers and decking, and the constant traffic of vehicles and troops was stressing a bridge that was never designed for such loads. More critically, the Germans were now throwing everything available at the bridge, trying to destroy what they had failed to demolish. Artillery fire pounded the structure constantly. Aircraft attacked with bombs and experimental weapons. Frogmen attempted to float explosives downstream to destroy the supports. And through all of this combat, engineers had to work on under and around the bridge to keep it functional, to repair damage, to strengthen weakened areas, and to defuse German demolition charges that hadn't exploded but might detonate at any moment. The combat engineers assigned to Remagen came from multiple units. The 291st Engineer Combat Battalion, initially supplemented quickly by additional engineer companies as the scale of the work became apparent. These weren't rear-echelon construction troops. They were combat engineers trained to operate under fire, to build and destroy infrastructure in contested territory, to make rapid assessments of structural integrity, and make emergency repairs with whatever materials were available. But nothing in their training had prepared them for Remagen, for the scale of the challenge, or the intensity of enemy efforts to destroy what they were trying to preserve. The first task was clearing the German demolition charges. The bridge had been rigged with hundreds of pounds of explosives placed in critical structural points where detonation would sever supports and drop spans into the river. Some of these charges had detonated partially during the initial German attempt to destroy the bridge, but many remained live unexploded because of faulty wiring, defective detonators, or German engineer error under stress. Combat engineers had to locate every charge, determine if it was live, and either defuse it or remove it all, while German artillery was deliberately targeting the bridge, trying to trigger the charges through nearby explosions. This work required crawling through the bridge's superstructure, working in cramped spaces among steel beams and girders, handling explosives that might be booby-trapped or unstable, and doing so while the entire structure shook from artillery impacts. The casualty rate among engineers doing this work was staggering. Men were killed by artillery fire while working on exposed sections of the bridge. Others died when demolition charges they were trying to defuse exploded, either from instability or from nearby German shells triggering them. Some fell from the structure working on narrow beams hundreds of feet above the river. They lost their footing during artillery barrages or when the bridge swayed from the weight of vehicles. The work was conducted in shifts because no one could sustain the physical and psychological stress for more than a few hours. The combination of extreme danger, physical exertion, and mental strain of working with high explosives under fire was simply unbearable for extended periods. Beyond demolition clearance, the engineers had to repair structural damage and reinforce the bridge to handle traffic it was never designed to carry. The Ludendorff Bridge was built for railroad locomotives traveling at controlled speeds. Now it was carrying tanks, trucks, and thousands of troops crossing in both directions simultaneously. The stress was immense and visible. The structure swayed noticeably. Under heavy loads, supports groaned, and engineers could see cracks forming in critical members. Emergency repairs required working beneath the roadbed, installing temporary supports, reinforcing damaged sections, all while traffic continued flowing, because stopping crossings would waste the precious time the bridge was providing. The most dangerous work was conducted by engineer divers working in the Rhine itself, inspecting the bridge's underwater foundations and supports. The river was cold, fast-flowing, and contaminated with debris from upstream bombing. Visibility was essentially zero. The divers worked by field checking for structural damage, clearing obstacles, and watching for German sabotage attempts. They knew that German frogmen were attempting to float explosives downstream to destroy the bridge supports, that any unidentified object touching them in the murky water might be an explosive device, and that working beneath a damaged bridge that might collapse at any moment meant they could be crushed by falling debris with no warning and no chance to escape. The German efforts to destroy the bridge were relentless and increasingly desperate. Artillery fire was constant, with German gunners having pre-registered coordinates for the bridge and firing barrages whenever they suspected American forces were attempting crossings or repairs. The Luftwaffe, by this point, largely ineffective due to Allied air superiority, threw its remaining resources at Remagen, conducting bombing raids and even deploying experimental guided missiles, the V-2 rocket and the primitive Fritz X guided bomb, against the structure. None of these attacks managed to destroy the bridge, but they killed engineers working on and around it, damaged repairs that had just been completed, and created constant stress that exhausted the troops responsible for keeping the structure operational. On March 17, 1945, 10 days after its capture, the Ludendorff Bridge finally collapsed. The combination of structural damage from the German demolition attempts, stress from constant heavy traffic, weakening of supports from artillery fire, and simple fatigue of materials that had been stressed beyond their design limits caused a catastrophic failure. Sections of the roadbed dropped into the Rhine, taking engineers who were working beneath the structure at the time. 28 American soldiers were killed in the collapse, most of them engineers who had been conducting repairs. The tragedy was that by this time, American forces had constructed multiple pontoon bridges and ferries near Remagen, establishing crossing capacity that no longer depended entirely on the Ludendorff Bridge. The structure's collapse was devastating for the men who died, but strategically, it mattered less than it would have days earlier. But those 10 days had been decisive. In the time the Ludendorff Bridge remained operational, over 25,000 troops and thousands of vehicles crossed into the German heartland, establishing a bridgehead on the east bank of the Rhine that expanded rapidly. German forces that should have been defending other sectors were diverted to Remagen, trying to eliminate the bridgehead. German reserves that should have been preparing defenses elsewhere were committed piecemeal, trying to contain the American breakthrough. The psychological impact on German defenders was substantial. The Rhine, supposedly impregnable, had been crossed, and the myth of Germany's defensive invincibility was shattered. Most critically, the success at Remagen demonstrated that Rhine crossings were possible, encouraging Allied commanders to accelerate other crossing operations that had been planned for weeks later. The engineers who made this possible worked in conditions that infantrymen would have refused to accept. Infantry advancing under fire could take cover, could return fire, could maneuver to avoid danger. Engineers working on the Ludendorff Bridge were exposed targets, conducting complex technical work while under fire, unable to take cover without abandoning critical tasks, knowing that any moment might bring an artillery shell or structural collapse that would kill them. They worked around the clock in shifts, sleeping only a few hours before returning to the bridge, watching friends die, and then continuing the same work that had killed them because the mission required it and there was no one else to do it. The specific technical challenges the engineers faced reveal the complexity of their work. Structural assessment required understanding which members were load-bearing and which could be damaged without immediate catastrophic failure. This wasn't academic engineering, conducted with precise measurements and calculations, but field assessment done by eye and experience, often in darkness or while wearing gas masks against chemical contamination fears. Temporary support structures had to be designed and installed using whatever materials were available: timber from demolished buildings, steel from captured German supplies, equipment from engineer stockpiles that was never intended for bridge reinforcement. The repairs had to be strong enough to support immediate traffic but were acknowledged to be temporary. Perfection wasn't possible, only adequacy for the current mission. The demolition clearance work required specialized knowledge that few soldiers possessed. Identifying explosives by appearance and construction, understanding German demolition systems and circuitry, determining which charges were connected to which detonators, all of this required training and experience that combat engineers possessed, but that came with no guarantee of success. German demolition systems used multiple redundancies and sometimes booby traps designed to kill engineers attempting to defuse them. The men doing this work knew that they were gambling with their lives every time they touched a suspicious package or cut a wire that their expertise reduced, but could never eliminate the risk of triggering explosives that would kill them instantly. The broader context of combat engineer operations in World War II shows that Remagen was exceptional in its visibility but typical in its danger. Throughout the war, combat engineers conducted work that was essential to military operations, but that exposed them to casualties rates comparable to or exceeding infantry. They cleared minefields by hand, crawling forward to probe for mines with bayonets and marking safe paths while under fire. They constructed bridges under artillery bombardment, working in water or on exposed scaffolding while enemy forces targeted them. They demolished obstacles to armor advances approaching fortifications with explosive charges as well under fire from the positions they were trying to destroy. They cleared obstacles from landing beaches during amphibious operations, working in waist-deep water while machine guns fired over their heads. Every advance required engineers to make movement possible, and engineers paid for that possibility with lives. The recognition given to combat engineers was inadequate relative to their contribution and sacrifice. Infantry received the glory they closed with and destroyed the enemy. They captured territory. They were the visible symbol of combat. Engineers enabled all of this, but did so in ways that were less dramatic, less suitable for heroic narratives, and often literally invisible, because their work was conducted beneath, behind, or before the fighting that captured headlines. The men who kept the Ludendorff Bridge operational for 10 crucial days received some recognition medals, were awarded unit commendations were issued, but their contribution was framed as supporting the infantry and armor that crossed the bridge rather than as independent achievement that was equally essential to the outcome. The technical legacy of Remagen influenced post-war military engineering doctrine and bridge design. The U.S. Army conducted exhaustive analysis of the Ludendorff Bridge's construction, the damage it sustained, the repairs that were attempted, and the ultimate failure. This analysis informed bridge design standards, engineer training curricula, and doctrine for rapid bridge assessment and repair. The lesson that bridges could be kept operational far beyond their design limits through aggressive field repairs, and that this operational extension was worth accepting. High engineer casualties became embedded in military thinking about river crossings and infrastructure operations. The human cost of Remagen deserves emphasis because it's easily overlooked in strategic discussions of the Rhine crossing. Over 200 American casualties killed and wounded were sustained in the battle for and defense of the Ludendorff Bridge, with combat engineers suffering disproportionately high casualties relative to their numbers. These men died doing work that received minimal recognition, work that involved no dramatic charges or heroic last stands, but that required technical skill, physical courage, and acceptance of constant danger. They died defusing bombs, repairing structures, inspecting underwater supports, conducting work that saved thousands of other soldiers' lives by making the bridge crossing possible, but that killed them in ways that were mundane, technical, and utterly essential. The German perspective on Remagen reveals their recognition of the bridge's importance and their frustration at failing to destroy it. German commanders understood immediately that losing an intact Rhine bridge was catastrophic, that the bridgehead would expand regardless of counterattacks, and that the strategic implications of the loss might be decisive. The officers responsible for the bridge's demolition were court-martialed. Some were executed for failing to destroy the structure before it was captured, though the reality was that they had attempted demolition under combat conditions and that equipment failures beyond their control prevented success. The German forces attacking the bridge afterward knew they were attempting the impossible, destroying a structure that was now defended by American forces with air superiority and artillery support, but they attacked anyway because orders demanded it and because the strategic situation was so desperate that even futile efforts seemed necessary. The bridge's collapse on March 17th was both tragedy and validation. The tragedy was obvious: men died, and they died after the bridge was no longer strategically essential. But the collapse also validated the engineers' warnings that the structure was being pushed beyond safe limits, that temporary repairs couldn't indefinitely sustain the loads being imposed, and that eventual failure was inevitable. The engineers had bought 10 days through their work, and those 10 days proved sufficient for the strategic purpose. The collapse, when it came, was a technical inevitability rather than a failure of engineer competence or effort. The memorial that now stands near the former bridge site acknowledges the battle's importance but cannot fully capture what the engineers who worked there experienced. Visitors can see where the tower stood, can observe the Rhine River, and imagine the bridge spanning it, can read plaques describing the capture and collapse. But they cannot experience the physical sensation of working on a damaged bridge that swayed under traffic, the psychological stress of diffusing demolitions under artillery fire, the constant awareness that the next shell or structural failure might kill you while you were performing technical work that required concentration and precision. The memorial honors the achievement, but cannot convey the cost. The broader lesson of Remagen extends beyond the specific tactical situation to the fundamental nature of modern warfare. Victory requires more than fighting. It requires building, repairing, and maintaining the infrastructure that makes operations possible. Combat engineers bridge rivers, clear obstacles, repair roads, construct fortifications, demolish barriers, and perform dozens of other tasks that enable maneuver warfare and combined arms operations. Without engineers, armor can't advance because bridges are destroyed and obstacles block roads. Without engineers, infantry cannot assault because wire obstacles and minefields protect defensive positions. Without engineers, logistics cannot function because roads and bridges are damaged and bases lack infrastructure. The engineers who do this work accept casualties that would be considered catastrophic for other roles, yet they remain less recognized and less celebrated than the combat arms they enable. The Ludendorff Bridge at Remagen stands as the most visible example of this reality. For 10 days in March 1945, a damaged railroad bridge became the most important strategic asset in Europe, and keeping it operational required combat engineers accepting death and injury at rates that would have ended infantry operations. They worked in conditions that were physically exhausting and psychologically terrifying, conducting complex technical work while under fire, knowing that mistakes or bad luck would kill them, but that their work was essential to victory. The bridge eventually collapsed, killing engineers who were working to save it, but by then it had served its purpose. The Rhine was crossed, the bridgehead was established, and the end of the war was accelerated by weeks that saved thousands of lives elsewhere. The engineers who died at Remagen, crushed when the bridge collapsed, killed by artillery, while repairing damage, drowned while inspecting underwater supports blown apart, while diffusing demolitions, deserve remembrance as combat casualties, whose work was as essential to victory as any infantry assault or tank attack. They fought with wrenches and welding equipment instead of rifles. They died performing technical work instead of heroic charges, and they saved lives by building rather than destroying. Their memorial is the successful Rhine crossing, that the Ludendorff Bridge enabled the thousands of soldiers who crossed safely because engineers kept the structure operational, and the recognition, often inadequate, but sincerely meant that victory in modern war requires engineers willing to die doing work that earns few medals but enables everything else. The bridge at Remagen was captured by infantry held by combat arms, but it was kept operational by engineers who proved that the most dangerous job in World War II was often the one nobody noticed until it failed. And at Remagen it didn't fail until 10,000 soldiers had crossed into Germany and victory was assured.